Mr. Hessian, and this is your review day ed puzzle. So you're required to go through this ed puzzle, answer the questions to help you review for your test tomorrow. Okay, so I start off with this is a Schoology page, and there might be more of it listed on here, but let's just take a look at this weekly agenda. That's where you can find the information on what we're doing. I'm going to go ahead and click on the weekly agenda in another screen here so we can see it a little bit better, right? This is Wednesday, March 13th. So today, be good. Put your phone away. Sit in your assigned seat. You have a sub if you didn't notice. To do today is this ed puzzle. I hope you do this first. And then when you're done, grab the vocabulary crossword on the front card. There's a word bank at the bottom. Do that. And that will help you at least know the terms that are going to be on the test. And then finally, there's a link to a Kahoot. Play the Kahoot, and that will allow you to prepare for your test as well. Tomorrow is your climate factors test. Got it? So let's move over here to our test review. I'm going to go ahead and click slideshow. Okay, we start off with a graph. This graph shows temperature and time. I'm going to move this little thing down here real quick out of the way if I can. There we go. Okay, this is for Burnsville, Minnesota, and this shows the average high and low temperatures throughout the year. You can see on the y-axis the month. On the y-axis is the temperature in degrees Fahrenheit, and these are average temperatures of high and low. That's our climate. And then on the x-axis, we have the months of the year. All right, so as we take a look at this, one question might be, during what month do we have the highest temperature of the entire year? When could we expect the highest high temperature? Well, looking at the graph, you should find the highest point, 80.6 degrees is the highest one. And following that down, you should see that that would be in the month of July, okay? Which also has the highest low temperature, if I were to ask that. How about the coldest temperatures? In what month would we expect to have the coldest temperatures? For that one, come over here and take a look at January. January has the lowest high and lowest low temperature on the graph. Okay, how about today? Today is March 13th, 14th, wherever we are. So in the middle of March right here, let's say that we're right on the line, right? Maybe our average high temperature for the middle of March, since that is for March itself. So in the middle, we should experience a temperature of about 39.4 degrees Fahrenheit. All right, so our temperature today probably won't be 39.4. I believe when I made this video, the temperature was predicted to be about 46 degrees Fahrenheit. So what does that tell you? What does 46 degrees mean? Does that mean that we have global warming for sure? Does it discount global warming, or is there something else? Next, we have a rainfall graph, also for Burnsville. We'll take a look. So I could ask you, same thing. On the y-axis, we have inches of rainfall, and this is per month. Okay. So I would say, during what month do we tend to get the most rain? Right? During what month do we tend to get the least amount of rainfall? Then how about today again? Today, this is for the whole month. Do you think that this month that we would get 1.46 inches of rain? I don't know how much we've had so far. I hope you can read this okay. This is showing your vocabulary terms and definitions. And so we have latitude, altitude or elevation. I think I use elevation on the test. Orographic, we've used that a few times, so I want to make sure that you understand that. Gyre, ocean currents, wind, and windward. So the side of the mountain that the prevailing wind hits, the movement of ocean water due to wind or differences in density, a location's distance north or south of the equator measured in degrees, moving air, height above sea level, relating to mountains, especially with regard to their position and form, and a large system of rotating ocean currents. So let's match these up. Let's start with latitude. What's latitude? A location's distance north or south of the equator. What's altitude or elevation? Height above sea level. Orographic relates to mountains. A gyre is a large system of rotating ocean currents. I do the next two the same. Which one is ocean currents and which one is wind? Well, ocean currents would be the movement of ocean water due to the wind or differences in density, and wind is defined as moving air. And finally, windward, all the way up at the top, the side of the mountain that the prevailing wind hits. Okay, these are also, along with some others, on your crossword puzzle that you'll be doing after this. Okay, take a look at this. This is the relationship between latitude and temperature. This is a Mercator projection map, and we have the equator in the middle here. And what you should see here is as you move away from the equator using the scale at the bottom, I'll move this away. And this is from January to December in a certain date range. Equatorial areas tend to be warmer than polar regions, and so the general relationship is as you increase your latitude, go from 0 to 90, as you increase your latitude, the temperature decreases on average, all other things being equal. All right, climate factors. We've been doing climate factors, right? Let's take a look at these one at a time. This one shows ocean currents. So let's talk about ocean currents. Ocean currents, these are caused by a couple of things. The surface currents are caused mainly by prevailing wind patterns as well as the spin of the Earth, right? And so along the equator, you have what's called the North Equatorial Current and the South Equatorial Current, and those move from the west to the east. Now, in the northern hemisphere, because the Earth is spinning, it's causing fluids to be deflected to the right in the northern hemisphere. So you get this clockwise flow. We call this a gyre, North Atlantic gyre. Conversely, in the southern hemisphere, things are deflected to the left. And so you get what's called the South Atlantic gyre and so on. But that's going counterclockwise. All right. So what does that form around North America? We have the North Atlantic current that's warm. Why is it warm? Because it forms near the equator, and that's where it gets a lot of sunlight. That moves into the Gulf of Mexico and becomes something called the Gulf Stream, which is quite a large current, actually. And that is keeping the east coast of the United States warmer than it normally would be. And then as you move north and east, it actually keeps the climate up here in northern Europe warmer than it normally would be as well. As it descends, as it moves southward again, now it's colder because it got cold up there, and now it becomes what's called the Canary Current, named for the Canary Islands there as it rejoins. So that's a gyre. On the west coast of the United States, you have this cold current called the California Current, which keeps the climate and waters off the coast of the west coast of the United States, specifically California, colder than they would normally be. And so you have a cooler climate over here and a warmer climate on the East Coast because of these currents. Now, just proximity to water, though, remember, has a moderating effect. What does that mean? A moderating effect means that cities on the coast don't get as hot nor as cold as cities inland, all things being equal, right? So in Minnesota, we get really hot summers, over 100 degrees is not uncommon, and really cold winters, we can be 20 or 30 degrees below 0 Fahrenheit. That would be unheard of on the West Coast because of the ocean. All right. Temperature and altitude or elevation. The general rule is, all things being equal, as you move upward in elevation, your temperature decreases. So why is Death Valley so hot? One of the reasons is because its elevation it's the lowest elevation in the continental United States, or all of North America possibly, and so that low elevation, you get very hot temperatures with that. All right, this diagram kind of nice. It shows pressure zones. Okay. We talked briefly about this. We said that the equator has what's called low pressure. Low pressure just means the air isn't pushing down on it as much. Well, why is that? Well, because the air is warming. It's warm, it's humid, it's rising. And if it's rising above you, it's pushing on you less. We call that low pressure. But also what happens then is as it rises, it cools and forms clouds. And those clouds then form rain, and you get along a low pressure area like this equatorial low, a lot of rainfall. Now switch that to about 30 degrees north or south, and the opposite happens. This is called a subtropical high. And so what's happening here is there's high pressure, which means air is pushing down on you if you're at 30 degrees north and south. And so now you're not getting the clouds forming. In fact, it can be quite sunny and not a lot of rainfall. This is where we see a lot of deserts, right? The Sahara Desert is right at 30 degrees north. Okay. We can go further. 60 degrees north and south are low pressure again, so you get more rainfall there. And then at the poles, 90 degrees north and south is dry again. I've got this diagram. It's kind of hard to see possibly. Especially this red part kind of got blurred out. But this is kind of, if you look in the middle, that'd be the equator. And as we move toward the left, we're going 30 degrees north, 60 degrees north, and then the North Pole. And then to the right, 30 degrees south, 60 degrees south, and the South Pole, if you kind of understand what's happening there. So I'll try to move this out of the way. Again, along the equator, it rains a lot. You can see the rain clouds here. Rain all year is what that blurry part says. Then if we skip over to 30 degrees north, this high means it's high pressure, dry all year. 60 degrees north, precipitation in all seasons, more in summer. All right. So where are we? We're kind of in this area. Winter rain, summer dry, slight winter rain. All right. We're kind of at 45 degrees north. We're probably closer on the edge of this 60-degree area where we do get precipitation in all seasons. All right. So this is kind of showing the high and low pressure belts and how they affect climate. Once again, 0 degrees, wet, 30 degrees, dry, 60 degrees, wet, 90 degrees, dry. All right, orographic effect, right? A mountain. You have a prevailing wind coming off of the ocean that picks up moisture. As it rises, it cools, the water changes into liquid, and it rains. And so the windward side of the mountain is this side. We call that the windward side, and it tends to be cooler and wetter. Then as the air then descends on the leeward side, moisture remains in the atmosphere as water vapor, and so you tend to get warmer, drier conditions on the leeward side. Sorry, this is blurry. It's got this one as actually an example that's on your test. So let's take a look at some of these fictitious areas on this map. I might ask you, between A and B, what's the difference in climate? So point A is here. It's on the windward side of mountains. B is on the leeward side, right? There's a prevailing wind. You should say that A would be a more moderate climate. It's closer to the ocean, cooler climate, and a wetter climate. All right. B would be drier and warmer. It's like Seattle and Spokane, like we talked about in class. All right. How about C and D? C and D, well, they're both inland, but C is at 30 degrees north. D is closer to the equator. And so D, you would say, would be warmer than C. And you might say that D is wetter than C also, because C is in that 30 degrees north latitude area where you get the high pressure. How about this one? This is also from your test. Let's take a look at what's the difference between what would be warmer, G or F? Okay. Well, F would be warmer because it's on the coast. It's lower altitude. G is in the mountains. F is also on the eastern side, and so you would tend to have warmer currents on that side compared to this side. On the east coast, you tend to have warmer currents. West coast, you tend to have cold currents, right? What about H and C? You have the orographic effect again, right? E would be cold because it's so far north compared to A, and so on. So I should be able to pick out some of these and say, hey, tell me, what's the difference between the climate of them, and knowing your climate factors and how they affect things. Hopefully you can answer those questions. Okay. All right. And that is it. That's the one I was looking for before. There it is. Okay. So that's it for your test review. Go ahead and finish up this Edpuzzle and submit it. And then next do your crossword puzzle and then the Kahoot. All right. Good luck.